This question says, classify the given function as polynomial, rational, or root, and then find the domain. Write the domain in interval notation. Our function is g of x equals the 8th root of 8 minus x. So looking at this function, you can see that it has a radical. And so we're going to categorize this as a root function or radical function. And we have two categories within that. We have an even index and an odd index. So what the index is referring to is this 8. That is the index on the radical. And because it's an even number, we would say that this is an even root. Now, the significance of it being an even root is to do with the domain. If you have the even root, I'm going to say in root, and n is even. If you have the even root of a positive, that will give you a real number. If you have the even root of 0, that's going to give you 0, which is a real number. However, if you have the even root of a negative, this comes out to be imaginary or complex, which is not a real number. And so we only want to have real values of the function, so we want to restrict which type of numbers we substitute into this. We want positive numbers underneath the even radical and 0 underneath the even radical. So if we're looking for the domain, we're going to take what's underneath the radical, x minus 8, and we want that to be greater than 0 or equal to 0, because those are the numbers that are going to produce real outcomes, real number outcomes. So we'll solve that inequality. We have negative x is greater than or equal to negative 8. I'll divide both sides by negative 1, and when I divide by a negative, I reverse the inequality symbol. And so my domain is going to be from x is less than or equal to 8. And I want to write that domain in interval notation. So I'll write the number line. I'm going to mark 8 on the number line with a filled in dot. I'm marking a filled in dot because x can equal 8. And then I would shade values that are less than 8. So they're going to be values over here to the left of 8. And I want to represent that interval with interval notation. That interval will start at negative infinity and stop at 8. For negative infinity, we use a parenthesis next to that. And for 8, we'll use a bracket to represent that 8 is included. So it's the same thing as a filled in dot. And that is our domain from negative infinity to 8. This question says, use the graph of y equals f of x to answer the question. On what intervals is f increasing, decreasing, or constant? And this is the graph of f, and we see it in red here. And we want to find the intervals for which f is increasing, decreasing, or constant. The words increasing, decreasing, and constant are all referring to the y, what's happening with y, and the intervals are going to be the x. So we're going to describe what's happening to y, but we're describing it on intervals of x. So I'm going to start by just getting an overall understanding of what's happening. I'm going to trace the graph moving from left to right, And I'm moving from left to right to go from smallest to largest. So as I trace this portion of the graph, the y values are constant. We have a y value of 7 along this entire piece, so it's constant. Then the y values are decreasing, then increasing, then decreasing. Then the y values are increasing, decreasing, increasing, and then constant. I'm going to try to label the graph so that I can see all of these pieces separately. So let's start with blue for constant. These sections are constant. We'll go with green for decreasing. So it's decreasing along this section, and this section, and this section. And how about purple for increasing? So this is increasing, increasing, and increasing. So now that I've got an overall feel for what's happening with the graph, I want to write down the intervals. And as I said earlier, the intervals are referring to the x. So if I'm looking at this section of the graph here where it's constant, this x is starting at negative infinity and going all the way up until this x of negative 6. So I'm going to say that this graph is constant, starting at negative infinity and going to negative 6. And depending on your book's definition of increasing, decreasing, and constant, you might put a bracket on this or you might put a parenthesis. For our college algebra book, we use a parenthesis. And then this piece of the graph is also constant, starting at 6, going to infinity. So it's also constant from 6 to infinity. And let's do the decreasing. So on the decreasing section, starting here, it starts at negative 6 and stops at negative 5. We're decreasing on the interval from negative 6 to negative 5. And then again on this section from negative 4 to 0. And then again from 4 to 6. And then we have increasing on the purple sections. That's starting at, I think I need to erase a little bit because I'm getting messy. I can't see my values anymore. So this purple section is starting at negative 5 and goes until negative 4. And this purple section starts at 0 and continues to 4. This one starts at 5 and goes until 6. So those are my intervals of increasing. It's increasing from negative 5 to 4, union with 0 to 4, union with 5 to 6. This question says, write the equation for the graph. And we have a picture here of a horizontal line that looks like it passes through negative 2. So I'm going to keep in mind that this is a straight line, and in slope-intercept form, that straight line has the equation of y equals mx plus b, where m is the slope and b is the y-intercept. So if I can identify the slope and y-intercept of this equation, I'll be able to write the equation of this graph. So I'm noticing that this graph has a y-intercept at 0, -2. So that means that b is equal to -2. And then I also know that horizontal lines have a slope that is 0. So the slope is 0. And I can write the equation of the line as y equals 0x plus -2, which is y equals -2. So the equation of the line, the equation of this graph, is y equals -2.